What happens with electric car batteries at their end of life? What are actually the critical raw materials that go into battery manufacturing, and can we really recover those valuable materials through recycling? Hi everybody, my name is Veronika, right? Or Electrified Veronika. I am a consultant in the battery electric vehicle area, and today we're talking about battery recycling. I know that many people are very skeptical about recycling in general, and especially now that the automotive market with electric vehicles is growing very fast, everybody is wondering, what happens to these batteries? Will they end up in landfills? We will meet a company, a startup in Munich, Germany. They're called Reco-E, and they are working on recycling electronics for the past 25 years. And for the past 2 years, they started recycling electric car batteries.
So we can recycle batteries from a Tesla, from an e-tron, from scooter batteries as well. And we bring that into metal powders that our customers are using in additive manufacturing.
Reco-E's mission, or the vision of the founder, is really to get back almost 100% of the very valuable raw materials that go into batteries by reverse manufacturing and a little bit of chemistry.
We have about 25 years of experience of electronics. We spent a lot of time to understand how these systems were produced, which materials went into during the production. And if you understand how these different systems were brought together, then you understand how to recycle them. And our idea was kind of to optimize the recycling process, not lose any materials, also the rare earths or the lithium from the industrial batteries. It's limited sources on the earth, and we want to recycle them in full to really bring them back from the already used batteries.
One fact that I want to bring up in the very beginning, before we even start talking about if battery recycling is possible and how it works, is that there is regulations put in place in order to kind of force battery recycling and battery reuse. At least in Europe, it is a current requirement that 50% of the battery weight needs to be recycled. So if you have a 40-kilogram battery module, just like the one from a Mustang Mach-E produced by LG Chem, you have to get out at least 20 kilograms of raw materials with your recycling process. This requirement will increase over time, and at some point it might turn into something where we say what goes in should go out.
With the reverse engineering basically of the industrial batteries, we can recycle 94% of the lithium, we can recycle 99-point-something% of the nickel, as well as with all the other elements. Every material that went into these batteries during their production, we can recycle.
Very, very important, and I can't mention this enough, is that the European Union has the recycling target that every lithium-ion battery produced in 2030 in Europe has to have a certain amount of recycled material in them. This would, for example, mean that every new battery produced in 2030 has to have 4% of recycled, so secondary raw material lithium and nickel, as well as, for example, 12% of cobalt.
There are a lot of companies that are already interested in secondary raw materials to reduce their CO2 footprint.
What does all that mean? It means there is pressure on this industry, not only the automotive industry, but of course also electronics industry, laptop batteries, scooter batteries, all that. We need to create a circular economy.
The resources on Earth are limited, so the Earth is round, and we have lots of mines in Africa, we have lots of mines in South America, and it's definitely not green what we do in there. Once the material is mined once, we just need to keep that materials in a closed circle.
A circular economy, or the battery biography, how I call it, means that we are leading materials in a circle. Instead of having a linear production, so we make a product, we use it, and then we don't think about it anymore. We make a product, we already think about how can we reuse and recycle this material, and these secondary raw materials will enter the next production cycle, which means recycling turns into a local mining opportunity.
Metals you can recycle infinitely. We don't need to mine the materials anymore. We have enough materials, like the gold and the palladium is enough to produce more and more materials. And when I see that only 55% of the electronics is recycled in Europe and only 45% of the materials are then collected before that. And so we need to be really be careful with the materials that are in Europe. Russia and China have stopped exporting the rare earth materials. We have plenty of rare earth materials in these electronic boards. And so if we recycle that wisely, it's definitely a ways forward of reducing CO2, of reducing production or transportation of materials over the oceans from Africa, from America. So we have plenty of materials in Europe already. And with that, we just need to work wisely.
So now let's talk about how do we recycle lithium-ion batteries. In general, there are 3 different methods: hydrometallurgy, pyrometallurgy, or what they call direct recycling. It can also be a mixture of those. Direct recycling means when you start with a battery pack, you disassemble the battery pack into the modules, you disassemble the modules into the cells, for example, this pouch cell here, and then you open up this cell and break it down to the cathode and anode level, and then you reuse the cathode for a new battery. So we're not breaking it down to the raw materials themselves, but we stop at the cathode and anode level and then reuse those electrodes, it's mostly the cathode, that would be reused for new batteries. This is a fairly new concept, I would say, but I've seen some nice research papers where they could actually demonstrate that a battery made of a reused, recycled cathode material performs even better than the original one, and the reason would be a different microstructure of this electrode. Right now, I would say most of the other processes that I see would shred the battery at some point into smaller pieces, and then either using pyrometallurgy or hydrometallurgy to work on what they call is the black mass. The black mass looks like a black mass. It's a black conglomerate of materials, and then you have different mechanical, thermal, chemical processes to really try to get back those raw materials. In this video, we are talking about a different concept by Reco-E, which they call battery reverse manufacturing.
Currently, we do about 3 tons of electronic waste a day and about 2 tons of industrial batteries a day. So we do about 10 batteries, 15 batteries a day.
So what you get in is really the big packs or bigger modules. Then I'm assuming you start kind of disassembling them into the individual cells and then like reverse manufacturing, taking them all apart. And at some point you end up with
the powders that we have, yes. So basically, yes, normally we buy large portions of waste, which is not waste because there's really highly valuable materials in there. So we buy a truckload of electronics, some batteries are in there. First thing that we do when we get industrial batteries, we make sure that they're unloaded, that they're uncharged, disassemble them, reverse the production process. All the rolled batteries, the battery cells, we unroll, we unfold. You bring all the different elements into their soul stadium again. Chemistry is basically broken down into mass. We have large water tanks with fluids in there where we give the materials, we give them time to find their partner. They have attractors, separators, and with that process, slowly but surely, the gold finds to the gold, the copper finds to the copper, the lithium finds to the lithium.
The amount of different metals or elements that we have in products in general are increasing and increasing, and this of course complicates the recycling process in general. Although I learned from Rudolf that a battery only has 1/6 of the number of different metals or elements that you would, for example, find in electronics. How is battery recycling different from recycling electronics?
Basically, it's way easier.
It is easier?
It is way easier because if you see that, this car contains about 61 elements. A battery from a car contains about 7, 8 different elements, mainly lithium. Cobalt, nickel is in there, a lot of alloy for the box basically, a lot of copper, but this is basically it. So there's hardly any other elements. In total, it's like a fifth or a sixth of the magnitude of the multitude.
A very, very important portion to make battery recycling happen is, of course, to bring down cost, so it would cost less than mining new materials, as well as reduce the GHG footprint as much as possible.
When I compare the CO2 that goes into a copper, if it's mined, 1 kilogram copper has 7 kilograms of CO2, which is astonishingly high. And if you recycle that, it's only 1 ton, and we are able to produce that with only 100 grams of CO2.
I see a lot of battery recycling companies that are looking for facilities right now where they would have access to renewable energy. Rudolf, by the way, told me that they're reusing old solar panels on top of their facilities to power their recycling process. They're not only recycling materials and reusing solar panels, but also something else. You're not only reusing and recycling materials, but also machines.
We learned that there are no machines in the market available that will follow our process, which is understandable because it's our own process. We need to build the machines ourselves, and of course we don't build this from scratch. We buy used machines and we give them a second or maybe third life. This one is an old 𝗟𝗏𝗏𝗏. For this machine we could use even the 3 by 3 millimeters, and it would grind that into that portion, and with a different sieve you would go from that powder to that powder. This is for high quality, high purity powders, and for the magnitude for these powders like the 4 tons. Of course we wouldn't do that with that small machine, but we have like the big brother, which just wouldn't fit in the room in here. This would be the standard powder for a 3D printing, for EOS or Trump laser sintering printing. And this is chemistry in automotive. So you would use that powder to grind that on a surface of an electronic connector to optimize the acceleration basically.
What's the value of this powder here?
This is a 20 nano powder. The gram of that is 3,000 euros.
Let me take this one as a gift from me.
Everybody's doing that. Everybody.
I am sure you have realized that the electric vehicle market has kind of reached its tipping point, and we can expect hundreds, thousands, and even millions of tons of batteries that we need to recycle in 2030. This is, by the way, a mixture of production, scrap, and end-of-life batteries. So overall, we're expecting lots and lots of batteries from battery electric vehicles, but also fuel cell electric vehicles, or even from other industry. All the portable electronics, the maritime industry is switching over to battery powered, or stationary energy storage systems. Very important conclusion for this video. Battery recycling is possible. Yes, there are challenges, and it's a part of an economy that we still need to build. It's a circular economy that we want to prefer over a linear one. I hope this video gave you kind of an overview of what's going on in the battery recycling world. I really enjoyed my trip to Germany, Europe, and there are 2 more videos coming up about how long do batteries actually live, how can we maximize the lifetime, as well as what is the value of a used electric vehicle. So look out for these videos and do not forget to subscribe.